Question 3. All right, I've got a curve with this equation where x is positive, and I've got points A, B, and C on the curve, and I'm given the x coordinates, and I need to find the gradient of the curve at those 3 points. So the first thing I need to do is to differentiate to get the gradient function. So I'm going to rewrite this equation, writing this last term as x to the power of minus 2, because that will make it easier for me to differentiate. So when I differentiate this, I get 6x minus 2x to the minus 3, which I'm going to rewrite as 6x minus 2 over x cubed. Now I need to find the gradient of the curve at 3 points. I need to find the gradient of the curve when x equals 1. Well, in that case, the gradient is going to be 6 times 1 minus 2 divided by 1, so the gradient will be 4. I need to find the gradient of the curve when x equals 2, and at that case, the gradient will be 6 times 2 minus 2 over 2 cubed, which is 8. So that's 12 minus a quarter, 11 3/4. And I need to find the gradient of the curve when x equals 3, at which point the gradient will be 6 3s are 18, minus 2 over 3 cubed, 2 over 27. So 18 minus 2 27ths is 17, and 25 27ths. And that's question 3 sorted. Question 4. Calculate the x-coordinates of the points on the curve with this equation at which the gradient is equal to 16. So I need the x-coordinates of the points where the gradient is equal to 16. So what I'm going to do is I'm going to take my function and I'm going to differentiate it. And then I'm going to find the x values that give me a gradient that is equal to 16. So I'm going to find the x values which make the differential equal to 16. So this is the equation here that I need to solve. So I'm going to set it equal to 0, and I'm going to work with positive x squared. So I'm going to write 3x squared minus 14x plus 16 equals 0. Right, so how do I solve this quadratic? Well, I'm going to look to factorize it. I can't find a common factor there, so I'm going to see if I can't factorize this into 2 brackets. Otherwise, I might have to resort to using the formula. I've got 3x squared, so it's going to be 3x and x. I've got a positive 16 and a minus x term, a negative x term, so I'm going to have a minus and a minus. Now, multiplying to 16, well, let's try 2 and 8. Shall we? If I put an 8 here, then I get minus 8x's, and 2 there gives me another minus 6, which gives me the minus 14. So that's factorized. And so my 2 solutions are that x equals 2 or x equals 8 over 3. Let's just check the question. Calculate the x-coordinates of the points on the curve with that equation where the gradient equals 16, and there are the x-coordinates of the 2 points. Question 5. Find the x-coordinates of the 2 points. There's a clue. 2 points on the curve with that equation where the gradient is 1, and then find the corresponding y-coordinates. So I'm going to start with the equation of my curve, and I need to find the x values which make the gradient, give me a gradient of 1. So I'm going to find the gradient function, 3x squared minus 11, and I need to find the values of x which make that gradient equal to 1. So I'm going to solve that equation. So 3x squared equals 12, x squared equals 4, x equals plus or minus 2. So find the corresponding y-coordinates. Well, we know that y is x cubed minus 11x plus 1. So if x is 2, then y is 2 cubed minus 11 2's plus 1. 8 minus 22 is minus 14, plus 1 is minus 13. So that's the point 2 minus 13. And the other possibility was x is minus 2, in which case y is minus 2 cubed minus 8. Minus 11 times minus 2 is plus 22 plus 1. Minus 8 plus 22 is 14, plus 1 is 15. So that's the point, minus 2, 15. And that is the solution to number 5. Question 6. The function f is defined by f of x is x plus 9 over x, where x is a real number and x cannot be equal to 0. That's simply to make sure that 9 over x works okay. Right, part A, find f dash x, find the differential. So for part A, I'm going to rewrite f of x as x plus 9 times x to the power of minus 1 to make it easier for me to differentiate it. And that gives me a differential of 1 minus 9 times x to the power of minus 2, which I'm going to rewrite as 1 minus 9 over x squared. Right, part B, solve f dash of x equals 0. So I need to solve this equation. 1 minus 9 over x squared equals 0. If I multiply everything by x squared, I get x squared minus 9 equals 0. Add 9 to both sides and square root. So x could be plus or minus 3. And that is the solution to number 6. Question 7. Oh, I'm liking this. Given that y is this function here, find dy by dx. So let's write down the function first. Y is 3 root x minus 4 over root x. So I'm going to rewrite that using indices. So the root of x is x to the power of a half minus 4 times by x to the power of minus a half. So that is what I'm going to differentiate. So dy by dx will be a half times 3, and then x to the power of a half minus 1 is minus a half. Right, minus 4 times minus a half is plus 2. X to the power of minus a half minus 1 is not minus 1 half anymore, it's minus 3 halves. And there is the solution to that question. I suppose I could rewrite it, couldn't I, into a form which I would find easier. And so I'm going to have plus 2, and then I'm going to have x to the power of 3 over 2 as the denominator here. So you could write that, I suppose, as root x cubed if you wanted to. That's number 7 done. Question 8. A curve has this equation. Show that dy by dx is equal to this. Right, well, let's start with our equation here, which is y equals 12x to the power of a half minus x to the power of 3 over 2. And let's differentiate that. Dy by dx equals 6x to the power of minus a half minus 3 over 2 x, 3 over 2, 3 halves minus 1 is 3 halves minus 2 halves, just gives me a half. So that's what I've got for my dy by dx. Now it's asking me to show that dy by dx is equal to 3 over 2 x to the power of minus a half multiplied by 4 minus x. Now I've got a choice here. I can either factorize my expression on the left. I could factorize that expression and show that it equals this. Or I could take this expression here, multiply out the bracket and show that it comes to that. I'm going to do the latter. It doesn't matter which one you do. So I'm going to take their expression here. I'm going to multiply out this bracket. So 3 over 2 times 4 is 6. And then I have x to the minus a half. And minus 3 over 2, the coefficient's 1 on the x. Now I've got x to the minus a half multiplied by x. Remember, that's x to the 1. So add the indices. Minus a half plus 1 is a half. And look at that. That equals the expression which I had here. So all well and good. And I have done what they've asked me to do. In part A, I've shown that the differential is equal to this expression. Right, part B. Find the coordinates of the point, only one point, on the curve where the gradient is 0. Right, so I need to put my differential, dy by dx, equal to 0 and find which x's are solutions to that equation. Now, I'm going to use their version of the differential. A little hint for you, that's often the case that part A is supposed to help you with part B. So you'd be foolish not to use their version. So there is their version, and I need to find the solutions to that equation. Now, it's already factorized, of course. So what I'm looking at here is for the left-hand side to equal 0. Well, that would imply that, well, 3 over 2 can't equal 0. Now, x to the minus a half, that's 1 over the square root of x. Well, that can't equal 0. So that's not going to help me. But 4 minus x, now that can equal 0 when x is 4. So that's the x-coordinate of the point, which has a gradient of 0. And I've been asked to find the coordinates of the point, so I'm also going to have to find that y-coordinate as well. So remembering that y is 12 times x to the power of a half minus x to the power of 3 over 2. I'm going to need to put x is 4 in there, so that's going to be 12 times the root 4, 12 times 2, minus root 4, which is 2 to the power of 3. So that's going to be 24 minus 8. So y will be 16. So the point on the curve where the gradient is 0 is the point 4, 16. And that is question 8 complete. Question 9. Right, I need to, for part A, expand these two brackets. So I have got x to the power of 3 over 2 minus x, lots of x to the power of minus a half plus 1. So I'm going to multiply the second bracket by x to the power of 3 over 2 first. So x to the power of 3 over 2 times by x to the power of a half. Well, if you add those indices, you simply get x to the power of 1. X to the power of 3 over 2 multiplied by plus 1. Minus 1 times x to the power of minus a half. And minus 1 times 1. Okay, that is the brackets expanded. So let's have a look at part B. Part B, right, a curve has this equation. Okay, well that's obviously the same expression as in part A. Differentiate the curve, find the differential. So I'm going to need to differentiate this expression here. Okay, so dy by dx will be, well, x differentiates to 1 plus 3 over 2 times the coefficient there, so that's 3 over 2 times 1, x to the power of a half, minus a half times minus 1 is plus a half, x to the power of minus a half minus 1 minus 3 over 2, and the minus 1 differentiates to give me 0. So that is the equation differentiated. Use your answer to part B to find the gradient when x equals 4. Well, let's evaluate dy by dx when x is 4. So when x is 4, I'm going to have 1 plus 3 over 2 multiplied by the square root of 4 plus a half multiplied by, well, that's going to be 1 over 4 to the power of 3 over 2. So that's the square root of 4 cubed. Okay, so that's going to be 1 plus 3 over 2 times 3. Sorry, 3 over 2 times 2, because the square root of 4 is 2, it's just 3, plus a half times 1 over 2 cubed is 1 over 8. So it's going to be 4 plus a 16th. So the gradient of the equation when x equals 4 is 4 and a 16th. Question 10. I have to differentiate this expression with respect to x. So let's rewrite this expression, making sure that it's all going to be straightforward to differentiate. So I'll write that as x to the power of a half. I'm going to split this fraction, so it's going to be x squared over x squared plus 2x over x squared. I can simplify that further, of course. 2x cubed plus x to the power of a half plus 1 plus, that's going to be 2 over x, isn't it? Okay, so I'm going to write that out again. To write that 2 over x, that's 2 times x to the power of minus 1. Now, it's very easy to differentiate now. So my differentiated function will be 6x squared plus a half x to the minus a half 1 differentiates to nothing, minus 2x to the power of minus 2. So there is my answer to number 10. Question 11. Right, I've got a curve with this equation here, and I'm told that the curve, first of all, passes through the point 1, 2. And then I'm told that the gradient of the curve is 0. The gradient of the curve is 0 at the point 2, 1. So that's a second piece of information. Now, there is a third piece of information, and it's kind of hidden in that sentence. The gradient of the curve is 0 at the point 2, 1. Fine. The hidden piece of information is that the curve also goes through the point 2, 1. So I've actually got 3 bits of information here. Firstly, that the curve passes through the point 1, 2. So I know that the point 1, 2 satisfies that yellow equation. I also know that the curve passes through 2, 1. So I know that 2, 1 satisfies that yellow equation. And I know that the gradient of the curve when x is 2 is 0. So let's use those 3 pieces of information. Right. First of all, we know it passes through the point 1, 2, which means that we know, here's my original equation, y equals ax squared plus bx plus c. And we know that when x is 1, y is 2. So we know that 2 equals a plus b plus c. There you go. There's one equation. Okay, we also know that the curve passes through the point 2, 1. So I know that when x is 2, y is 1. So that gives me this equation here. Okay. In there, I've substituted in x is 2, and hence I've got 4a plus 2b plus c, and I know that that gives me a y value of 1. Okay, so that's the second equation. Equation 1, equation 2. Now the third equation is going to come from this fact about the gradient, because the gradient of the curve is 0 at the point 2, 1. Well, if I differentiate my curve, I'll get an expression for its gradient, 2ax plus b, and I know that 2ax plus b equals 0 when x is 2. So when x is 2 at the point 2, 1, I know that 2ax plus b equals 0. Well, x is 2, isn't it? So 4a plus b. That's an expression with the gradient when x is 2, and I know that equals 0. So there is a third equation. So now I've got 3 equations here with 3 unknowns. Okay, I'm just going to write the equations sort of next to each other so I can see what's going on. I've got this equation here. That was equation 1. Equation 2 is this one. Noticing, as I'm writing them out, I'm noticing those have both got one c in them, so I could eliminate the c by subtracting equation 1 from equation 2, perhaps. And here's equation 3. 0 equals 4a plus b. Okay, well, let's do equation 2 minus equation 1, which will give me, I'm doing equation 2, this equation, subtract the one above it. Okay, so I'm going to have 1 minus 2, which is minus 1, equals 4a minus a, 2b minus b, and the c's go. So now I've got an equation here, and I've also got this equation here. That's equation 3, isn't it? And look at that. If you subtract these 2 equations, I eliminate the b's, won't I? I'm going to do equation 3, subtract this equation here. So I'm going to have 0 minus minus 1 is 1, 4a minus 3a is a, and the b's go. So I already know now that a is 1. Well, by inspection, then if a is 1, looking at equation 3, then b must be minus 4. And now I can substitute into, it doesn't really matter which one I'll choose equation 1. Here's equation 1, 2 equals a plus b plus c. So I know that 2 has to equal 1 minus 4 plus c. So 2 is minus 3 plus c. So c is 5. So there we go. I think I found a, b, and c now. A is 1, b is minus 4, and c is 5. That question now complete. Question 12. Right. A curve has this equation, and part A says find dy by dx in terms of x. So we'll start off with y equals x cubed minus 5x squared plus 5x plus 2, and we'll differentiate that with respect to x. 3x squared minus 10x plus 5. That's part A done. Part B. Okay. Now in part B, I'm told that the points P and Q lie on C, and that the gradient of the curve at point P and at point Q is 2. And I'm told what the x-coordinate is of P. The x-coordinate of P is 3. So this point here must be the point P, and the gradient of the curve at that point is 2. So the gradient of the tangent at this point is also going to be 2. So there's the tangent at the point P, and that has a gradient of 2. Now, the point Q is the second point on the curve, where the gradient is 2. So looking at the curve, I'm thinking that Q is going to be somewhere here, because it looks to me, if I were to draw the tangent here, then it looks to me like that tangent will have about a gradient of 2 as well. So let's now find where the point Q is going to be, or at least find its x-coordinate, because that's what we're asked to do. So find the x-coordinate of the point Q. So I've got my equation of my curve here, and I've got the gradient function, and I know that at the point Q, the gradient is 2. So I'm going to set my gradient function equal to 2 to find out which x-coordinates give me a gradient of 2. Factorising this. Now I already know what one of the factors will be, because I know that one of the solutions is going to be x equals 3, because x equals 3 relates to the point P and the gradient is 2 there. So I know that that's going to be x minus 3 there, which means that this one must be 3x minus 1. Okay, so my other solution for x is a third. So the x-coordinate of Q, it must be 1/3. And I don't need to know what the y-coordinate is, but I now know the x-coordinate of Q is a third. Good, and that's part 1 done. Right, okay. Let's have a look at B part 2 here. Find the equation for the tangent to C at P. Okay, well I've drawn that red line already, so I need to find the equation of this red line. Okay, so I know a point on the line already is 3 minus 1, and of course I read off the minus 1 from my curve, but we could easily have substituted in the value of x into the equation of the curve and found out that y was minus 1 there. Now, do I know the gradient of that line? Yes, I do, because I know the gradient is 2 at the point P. So I've got a point on the line and the gradient of the line. So I can go y minus y1 equals mx minus x1. It's going to give me y plus 1 equals 2x minus 6. So y equals 2x minus 7. And that is the equation of the tangent to the curve at the point P. Right, so now I've just got part 3 to do. If this tangent intersects the coordinate axes at the point R and S, find the length of R and S, giving your answer as a surd. So what it's asking me to do here is it's asking me to find the points where this line, this is the line, y equals 2x minus 7. It's asking me to find the points where this line crosses the axes, and then find the distance between each of those, the distance of RS. Right, well my line is y equals 2x minus 7. When x equals 0, y is minus 7. So this is the point 0 minus 7. And when y equals 0, then x equals 3.5. So this is the point 3.5, 0, and I am being asked to find the distance from R to S. So that's okay. So x squared will equal through 7 over 2 squared, 3 over 2 squared, plus 7 squared. Okay, and I need to give my answer as a third. Well, let's just have a look at that. X would be the square root of, well, that 7 over 2 squared is 49 over 4 plus 49. Okay, so if I put that in my calculator, I get 245 over 4, and I need to square root that. If I square root that on my calculator and give my answer as a third, I get 7 over 2 times root 5, and that is the distance from R to S as a third, and that is question 12. Question 13. The curve has this equation here, okay, and I'm being asked to find the equations of the tangent and of the normal to the curve where x equals 2. Well, if I'm going to find the equations of two lines, for each line I need to know a point on the line and the gradient of the line. So I can find the point on each of those lines because I know that x equals 2, and I know that y is 8 over x minus x plus 3x squared. So if x is 2, then y is 8 over 2, 4, minus 2, plus 3 times 2 squared, 3 times 4. So that's going to give me 14. So my point on the curve, where x equals 2, is the point 2, 14. Now I need to know the gradient of the curve at that point, because that will give me the gradient of the tangent, and the negative reciprocal of that will give me the gradient of the normal. So let's start off by differentiating this expression. So before I differentiate it, I'm going to write it as y equals 8 x to the power of minus 1 minus x plus 3x squared, because I find that easier to differentiate. I'll differentiate it now. Minus 8 x to the power of minus 2 minus 1 plus 6x. So let's have a think. When x is 2, what is the gradient of the curve? Well, when x is 2, the gradient is minus 8 over 2 squared minus 1 plus 6 2s are 12. So that's minus 2 minus 1 plus 12. So the gradient is 9. So the gradient of the tangent will be 9, and the gradient will be 9, and the gradient of the normal, which I tend to call m1, will be minus 1 over 9. So let's write down the equation of the tangent, shall we? We know it goes through the point 2, 14, and we know it has a gradient of 9. So that equation is going to be y minus 14 equals 9 times x minus 2. Y minus 14 equals 9x minus 18. Y equals 9x minus 4. And now let's write down the equation of the normal. We know it's going to go through the point 214, but this time it has a gradient of minus a ninth. Y minus 14 equals minus 1 over 9 times x minus 2. I'm going to multiply everything by 9. 9 14s, 90 plus 36. And I'm going to multiply out that bracket, changing that sign. And so I get 9y equals minus x, what's that, plus 128. And so if I want to put it as y equals mx plus c, I get that. There we go. And that is the equation of the tangent and the equation to the normal, where x equals 2. Question 14. All right. We've got a curve here, which is given to us as 2y equals 3x cubed minus 7x squared plus 4. And we are asked to find the point at which these two normals cross. So I've drawn the curve in GeoGebra. Let's draw those two normals and see where they cross. Now the first one is the normal at 0, 0. So it's going to look something like that blue line there. And the second one is the normal at 1, 0. So that one is going to look something like that one there. Okay, right, and we need to find the coordinates of n, the coordinates of the point where the two normals cross. Right, let's start off first of all by finding the equation of that blue normal here, the normal at the point 0, 0. Now, if we're going to find the equation of a line, we need to know a point on the line. Well, we know that it goes through 0, 0, this blue line. We also need to know the gradient, so I need to find the gradient of that line. Now, the curve I'm dealing with is 2y equals 3x cubed minus 7x squared plus 4x. So let's make y the subject here. So I'm just simply dividing everything by 2. So there is my curve, and now to find the gradient of the curve when x is 0, I'm going to differentiate that to find my gradient function. That's going to give me 9 over 2x squared minus 7x plus 2. So there's my gradient function. So let's have a look. When x equals 0, then the gradient will simply be 2, which would imply that the gradient of my normal is going to be the negative reciprocal of 2, minus a half. So that's great. Now I can simply write down the equation of that curve. It's going to be y minus y1, but my point on the curve is 0, 0, isn't it? So y minus 0 equals minus a half x minus 0, or y equals minus a half x. So that is the equation of that blue normal there, the normal which goes to the point 0, 0. Now let's find the equation of the normal which goes through the point 1, 0, that red line there. Well, I already know a point on the line, of course, which is 1, 0. Now the gradient of the curve at that point, well, I know what dy by dx is, so all I need to do is to evaluate dy by dx when x equals 1. So I'm looking up here, and I'm substituting x. No, I'm not. I'm looking up here, and I'm substituting x equals 1 into my gradient function, which is going to give me 9 over 2 minus 7 plus 2, which equals minus a half. So that's the gradient of the curve there. So the gradient of my normal is going to be the negative reciprocal of that, 2. So the equation of the normal there, the equation at that line, is going to be y minus y1, so y minus 0 equals 2x minus 1. So that's going to be y equals 2x minus 2. So there we go, y equals 2x minus 2. There are the equations of those two normals, and in the question here I'm asked to find the coordinates of their crossing point, the coordinates of the point of intersection. So let's solve these two equations simultaneously, this equation here and this equation here. So I'm going to have minus a half x equals 2x minus 2. Okay, I'll subtract 2x from both sides. Minus 2.5x equals minus 2. And divide both sides by minus 2.5 gives me x equals 4/5. So that's the x coordinate of the point n. So now I need to find the y coordinate. So I shall simply substitute into one of my equations. I'm going to substitute into this equation here, x equals 4/5, which tells me that y will equal minus 2/5. So my point of intersection, the point n, has coordinates 4/5, comma, minus 2/5. And that is part A complete. 14b. Right, calculate the area of triangle OAN. Right, well, let's have a look at that triangle here. This is the triangle OAN. So I've got O here, A here, and N. And I know the coordinates of O and of A and of N. I'm simply being asked to find the area of that triangle there. Now, I know that O is the point 0, 0, and I know that A is 1, 0, and I know that N is, what was N? 4/5 minus 2/5. 4/5, comma, minus 2/5. So I know that the length of the base of the triangle there is 1, and I know that the height of the triangle is equal to 2/5. So the area of that triangle, let's do it down here, this is part B. So the area of the triangle is the base times the height divided by 2, which is simply 1 times 2/5 divided by 2, which is 2/10, which cancels down, of course, to a fifth. And that is question 14 complete. Question 15. Okay, right, so I have a curve called C with this equation here, and I know it cuts the x-axis at the point P. Okay, and then I have the line L is a tangent to the curve at P, and that line L cuts the curve at the point Q. Show that the distance PQ, I'm going to need to find the distance between P and Q, aren't I? Right, first things first, let's start off with my curve C, which is this one. And I know that it crosses the x-axis at P. So P is the point which has an x-coordinate of 0. And looking at my equation for my curve C, I can see that P will be the point 0, minus 1. Right. Okay. Now I need to find the equation of the line L. Now L is the tangent to the curve at the point P, isn't it? So I've got a point already, the point P, so I need to know the gradient of the curve at that point. So let's get the gradient function by differentiating my curve. And now let's evaluate that gradient function when x equals 0. When x equals 0, the gradient of the curve, and hence the gradient of the tangent, is minus 4. Okay, so I can write down the equation of that tangent now. It's going to be y minus minus 1 equals minus 4 multiplied by x minus 0. So that's simply going to be y equals minus 4x minus 1. And that is the equation of the tangent. Okay, now that tangent to the curve cuts the curve at another point. Look, cuts the curve at the point Q. So I need to find out when will L cross the curve C. So I've got the equation of L, and I've got the equation of the curve, and I'm going to need to solve those two equations simultaneously to find where they cross. So if I'm going to solve these simultaneously, I'm going to have minus 4x minus 1 equals x cubed minus 2x squared minus 4x minus 1. Right, if I add 4x and add 1 to both sides, I have 0 equals x cubed minus 2x squared. So then I'm going to factorize the left-hand side now. I can take out an x squared, can't I? Leaves me with x minus 2. So I know that the curve and the line cross when x equals 0 and when x equals 2. Well, I knew about the x is 0 anyway, because that's the point P. So the x-coordinate of the point Q is when x equals 2. So the point Q must be the point 2, comma what? Well, I'm substituting 2 into here now. So that's going to be 8 minus 8 minus 4 2's minus 1 is going to be minus 9. So my point Q is the point 2 minus 9. Right, now I'm on the last bit of the question. Show that the distance PQ, let's have a look at the distance PQ. Well, P is the point 0 minus 1 and Q is the point 2 minus 9. So the distance PQ is going to be the square root of 2 squared plus 8 squared. Looking at the difference of the x coordinates and the difference of the y coordinates, so that gives me the square root of 68. Okay, and 68 is 4 times 17, so the square root of 68 is 2 root 17, which is exactly what the question is asking me to prove, that the distance PQ is equal to 2 root 17. There's question 15 sorted. Question 16, right. I am told here that y is x to the power of 3 over 2 plus 48 times x to the power of minus 1. And in part A, I'm asked to find the value of x and the value of y when dy by dx equals 0. So let's differentiate to find dy by dx first of all. Okay, so there's dy by dx. I'm going to write that as 3 root x over 2 minus 48 over x squared, because I prefer that. Now we have to set that equal to 0. Okay, so I'm going to multiply everything by 2x squared there, make life a bit easier. So that's going to give me 3 times root x times x squared minus 96 equals 0. So I'm going to have 3 times x to the power of 5 over 2, that is, isn't it, equals 96. So x to the power of 5 over 2 equals, well, 3's into 96 goes 32. Now, what have I got here? Well, that's root x, isn't it? To the power of 5 equals 32. So if I find the fifth root there, then I'm going to have the square root of x equals 2, and so x equals 4. Well, that seemed a bit, I think I made that a bit more difficult than it was, really. There you go, so x equals 4, and I'm asked to find the value of x and the value of y. So when x equals 4, y, of course, is equal to x to the power of 3 over 2 plus 48 over x, which is going to be the square root of 4 cubed plus 12, which is going to be 20. So my answer to part A is the value of x and the value of y when dy by dx equals 0 is 4, 20. Right, now then part B, I need to show that that value is a minimum. So let's look at the second differential, shall we? So part B, here we go. The second differential, d2y by dx squared. I'm looking at this and I'm differentiating again. It's going to give me 3 over 4 x to the power of minus a half plus twice 48 is 96 x to the power of minus 3. Okay, let's write that a bit more kindly, shall we? So that's 3 over 4 root x plus 96 over x cubed. Now we need to evaluate that when x equals 4, or at least we need to know whether it's going to be positive or negative. But when x equals 4, both of those terms are going to be positive. So d2y by dx squared will be positive, which implies that 420 is a minimum. Show the value of y, which you found in part A, is a minimum. There you go. We have done that. And that's question 16 finished. Question 17. Okay. A curve has this equation determined by calculation of the coordinates of the stationary points. All right. So I'm going to need to find the points where the gradient is 0. So let's start off by writing down the equation of the curve. And then we'll find the gradient function, we'll differentiate it. It's going to give me 3x squared minus 10x plus 7. And I need to find the values of x, which give me a 0 gradient. So the values of x, which make that gradient function equal 0. Right, so I need to factorize this Here, obviously 3x and x. I'm guessing 7 and 1. They're both going to be negative, so I've just got to decide it's going to be 7 or 1, or 1 and 7. It's going to be 7 and 1. Let me just check that. Yes, it is. So the x coordinates of my stationary points are 7 over 3 or 1. Right, now I need to find the coordinates of stationary points, so I haven't finished yet. When x is 7 over 3, I need to find the corresponding y coordinate, which would be 7 over 3 cubed minus 5 times 7 over 3 squared plus 7 times 7 over 3 minus 14. I've just substituted my x value into there, of course. So a bit of calculator action tells me that the y coordinate there is minus 329/27. So that's 1 point sorted. Now the next point, a bit easier I hope, when x is 1, y is, I'm just substituting x equals 1 into here now, and I get 1 minus 5 plus 7 minus 14, which gives me minus 11. So my two stationary points for this curve are going to be when x is 7/3, y is minus 329/27, and also when x is 1 and y is minus 11. Question 18. We have a function and we're told the first differential, and we're asked to evaluate the second differential when x equals 4. So here is the first differential. So I'll differentiate that to get the second differential. And now we need to evaluate the second differential when x is 4. That'll be 2 4s minus 2 over 4 cubed. Right, put that into my calculator, and I get the answer 255/32. That's part A. Right, part B, prove that f is an increasing function. Okay, well, all I need to do is to prove that the first differential, which is x squared minus 2 plus 1 over x squared, is always greater than or equal to 0. Now, if you want to prove that something's always greater than or equal to 0, if you can prove it's a square number, then you've won the battle. And in fact, I can factorize this expression on the left. It's going to need to have an x and an x, of course. Right, and we're going to have a minus here, 1 over x and minus 1 over x, and that will multiply out to give me what I started with. So in fact, this left-hand side is a square number, and of course, a square number is always greater than 0 or greater than equal to 0. So I have proved that the gradient is always equal to 0 or positive, and hence f is an increasing function. Question 19. I'm given the equation of a curve, and I need to find the coordinates of its local maximum. Okay, so I've got y equals x cubed minus 6x squared plus 9x. Now I need to find the coordinates of its maximum. So I need to find the gradient function, and then I will set that equal to 0 to find the x coordinates of any stationary points. Let's divide by, well, let's take 3 out first. X squared minus 4x plus 3. Let's continue with our factorization here. X and x can be 3 and 1 minus 3 and minus 1. So I have stationary points when x equals 3 or 1. It's just a question of which of those is the maximum. So let's look at the second differential. d2y by dx squared. I'm just simply differentiating this now. That gives me 6x minus 12. So when x is 3, d2y by dx squared is going to be 18 minus 12, which is positive, so that would be a minimum. So that's no use to me. I imagine when x is 1, then this will be this second differential here, dx squared, it'll be 6 minus 12, which is negative, and so when x equals 1, I have a maximum, which is the point I'm interested in, isn't it? Find the coordinates of the local maximum. So the local maximum is where x equals 1, and y is what? Well, I'm substituting x equals 1 into there. Now 1 minus 6 plus 9 gives me 4. So my local maximum is the point 1, comma 4. And that is question 19 complete. Right, question 20. Right, in part A, I need to find the coordinates of the stationary points and determine their nature. Right, let's have a look. So we'll start by writing down the function. 3x to the power 4 minus 8x cubed minus 6x squared plus 24x plus 20. Now I'll differentiate that to give me 12x cubed minus 24x squared minus 12x plus 24. And of course I need to set that equal to 0 to find the x coordinates of the stationary points, to find the x coordinates at which the gradient is 0. I'm going to take 12 out to start with. Okay, and now I'm looking to factorize this expression here into 3 brackets. Right, now clearly I'm going to have an x, an x, and an x, and my 3 numbers in each bracket are going to have to multiply to plus 2, aren't they? Now I'm going to use the factor theorem here because I'm searching for a factor for this expression I've highlighted in blue. So I'm going to see if, for instance, that expression has a value of 0 when, say, x is 1, because if it has a value of 0 when x is 1, then x equals 1 is a root, and x minus 1 would be a factor. Now, when x is 1, looking at this blue highlighted expression here, I would get 1 minus 2 minus another 1 plus 2, which does give me 0. So x equals 1 is a root, and x minus 1 is a factor. By the same logic, I'm going to try and see if x plus 1 is a factor by evaluating the expression when x equals minus 1. And when x equals minus 1, that blue highlighted expression does indeed equal 0, meaning that x is minus 1 is a root and x plus 1 is a factor. Good. Now I can find my final factor simply by considering this plus 2 here, because I've got minus 1 times plus 1. And so what am I going to need to have in that third bracket? It's going to need to be a minus 2, so that when I do multiply out those 3 brackets, I have plus 2 as my constant term. Right, so I factorise there. My solutions are x equals minus 1 in the second bracket, or x equals 1, or x equals 2. So those are my x coordinates of the 3 stationary points. Now I need to find the coordinates of the stationary points, so each one of those x coordinates has a corresponding y coordinate, which I'm going to find by substituting my x coordinates into the function here. So a bit of calculator work tells me that when x is minus 1, y is 1. When x is 1, y is 33. And when x is 2, y is 28. So my 3 points are minus 1, 1, 1, 33, and 2, 28. Right, the next thing I need to do is to determine the nature of each of those stationary points. Okay, so when I'm determining the nature of each of those stationary points, I'm going to need to find the second differential and evaluate that for each of those values of x. So I'm looking at the first differential here, and I'm differentiating it again to find the second differential. So the second differential is going to be 36x squared minus 48x minus 12. And now I'm going to evaluate the second differential when x is minus 1. Now when x is minus 1, the second differential will be 36 plus 48 minus 12, so that will be positive. So when x is minus 1, we've got a minimum.
So this point here is a minimum. Okay, what about the value of the second differential when x is 1? Well, when x is 1, I'm going to have 36 minus 48 minus 12. So when x is 1, the second differential is negative, and I'm dealing with a maximum. So that's a maximum there. And lastly, what about the value of the second differential when x is 2? Well, when x is 2, I'm going to get 36 times 4 minus 48 times 2 is 96 minus 12. And that is positive. So therefore, when x is 2, I've got a minimum. So that's part A complete. We have found the coordinates of each of the stationary points, and we've determined the nature of each of those points. Right, part B, sketch the graph. Okay. Now, let's draw a set of axes here. Okay, so what do we know about this function then? Well, I know that its y-intercept is at 20. So let's put 20 here, and I know that's its y-intercept there. Now, I know it has a minimum at, let's make this 1, and let's make this 2 at 228. So I'm going to give it a point here. That's 28, and I know that that is a minimum, and I know it has a maximum at 133. So let's put that here. 33, 133, so that's a maximum. Okay, and I know it has a minimum at minus 1, 1 here. So there we go. There is my sketch of the function, and I have made it clear the coordinates of each of the stationary points. So that's the graph sketched, and that's number 20 complete. Question 21. Right, the diagram shows part of a curve which has got this equation. F of x is 200 minus 250 x to the power of minus 1 minus x squared. Okay. The curve cuts the x-axis at the points A and C. Okay. And the point B is a maximum of the curve. Fine. Okay, question A. Find the first differential. Okay, f dash x equals, it's going to be, 200 goes, doesn't it? Minus 1 times 250 plus 250, x to the power of minus 2 minus 2x. So that is the first differential, and that's question A done. Right, part B. Use your answer to part A to calculate the coordinates of B. Well, B is the maximum there, isn't it? So the point B is going to occur when the first differential equals 0. Okay, so this is the equation I've got to solve. So I've got 250 minus 2x cubed equals 0. So I've got 2x cubed equals 250. X cubed equals 125. So x is a cube root of 125, which is 5. Now I need to know the coordinates at that point. So I'm going to need to take x equals 5 and substitute that into my function, which is this one. So the value of that when x is 5 will be 200 minus 250 divided by 5 is 50 minus 25, which is 125. So the coordinates of B are 5, 125. Question 22. The diagram shows part of a curve with this equation. And the point P, which is x, y, lies on the curve, and O is the origin. Okay. Part A, show that OP squared equals that expression there. So what we've got here is we've got an equation for a curve, and we've got a point that lies on the curve, which we're calling P. That could be any point on the curve. Now, the coordinates we're given are P is x, y, but actually because P is on the curve, we know its x and y coordinates are connected, of course. If the x coordinate is x, then the y coordinate is 5, minus a half x squared. So that's going to be a better representation for the coordinates of P, because we know P lies on the curve. So those are the coordinates of P, and we need to show that OP squared is that. So we need to have a think really about finding the expression for the distance between O and the point, the general point on the curve at xy. Well, I'm finding that difference. I'm going to use this right angle triangle here. That's the x coordinate of the point P, and this vertical length is the y coordinate. So I can find OP squared by using Pythagoras. OP squared will be x squared plus 5 minus a half x squared squared. So if I simplify this expression, I'm hoping to get that expression there. So let's have a look. So that will be x squared plus, open bracket, 5 minus a half x squared times 5 minus a half x squared, which is going to be x squared plus 5 5s are 25. Then I'm going to get minus 2.5 x squares and another minus 2.5 x squareds. And then I'm going to get plus a quarter x to the power 4, which is going to be 25 minus 4x squared plus a quarter x to the power 4. Now I've been asked to show that OP squared equals that expression in the question, and look at that. I've done that, and so that's part A complete. Right, part B. Remember, in part A, we found an expression for the distance from the origin to any point on the curve. Now we're looking at part B. Now part B says, taking f of x to be 1/4 x to the power 4 minus 4x squared plus 25. So f of x is the distance between the origin and any point on the curve. Find the values of x for which f dash of x equals 0. So let's find f dash of x. And now we need to solve the equation x cubed minus 8x equals 0, which is going to give us x lots of x squared minus 8 equals 0. So my solution is going to be that either x equals 0 or x equals plus the square root of 8 or x equals minus the square root of 8. So there are three values of x which make f dash of x equal 0. Part C. Hence or otherwise, find the minimum distance from O to the curve, showing your answer is a minimum. Right, well, the distance from O to the curve is given by that function there. And I need to find the minimum of that function. So I know that the minimum of the function will occur either when x is 0, or when x is plus the square root of 8, or when x is the negative square root of 8. Those are all the stationary points. Some of them might be maximum, some of them might be minimum. I need to find out which ones of those are minimums. Well, to do that, I'm going to look at the second differential. So now I'm differentiating the first differential again. The second differential is equal to 3x squared minus 8. Now, when x is 0, the second differential is minus 8, is negative. So when x is 0, that's at a maximum. I want it to be at a minimum. So when x is plus or minus the square root of 8, let's evaluate 3 times, or the square root of 8 squared is 8 minus 8. Look at that. That's going to be positive. So the minimums occur when x is either plus or minus the square root of 8. Right? That is when the distance between the origin and the curve is at its minimum. Right? I've shown it's a minimum because I've shown that the second differential is positive. So now I need to determine what that minimum distance is. Now I've got an expression here for the square of the distance from the origin to the curve. So I'm going to substitute in x equals root 8 here. So now the square of the distance is 1/4 times root 8 to the power 4 times 4 times root 8 squared plus 25. Okay, so OP squared is, let's have a quick look at that. It's going to be, let's have a look. That's going to be 8 8s are 64. So that's a quarter of 64, 16 minus 32 minus 25, sorry, plus 25. So that's minus 16 plus 25, which is 9. So OP squared is 9. So the distance must be OT, must be the square root of 9, must be 3. So the minimum distance between the origin and the curve is 3. Question 23. Okay, the diagram shows part of a curve with this equation, and the curve touches the x-axis at A and crosses the x-axis at C. The points A and B are stationary points on the curve. Part A, show that C has coordinates 3, 0. Right, well, I've got the equation of the curve here. So all I need to do, I think, is to show that when the x-coordinate is 3, that the y-coordinate will be 0. So let's have a look. 3 squared minus 3 cubed, 27. So that's going to be 3 plus 15 plus 9 minus 27, which equals 0. Therefore, 3, 0 is point C. There we go, that's part A done. Part B, using calculus and showing all your working, find the coordinates of A and B. Well, A and B are the stationary points on the curve. So I'm going to write down the equation of the curve, and then I'm going to differentiate that to find the gradient function. 5 plus 2x minus 3x squared, and I'm going to need to set that equal to 0 to find the x-coordinates of the points which have a gradient of 0, because A and B are both points which have a gradient of 0. Right, so I'm going to need to factorise this. I'm going to need to have an x there and a 3x here. Now I've got 5 multiplied to 5, so I'm looking for 5 and 1 basically, or 1 and 5, I guess. Let's have a think. If I put the 1 here, the 5 there, then that gives me minus 3x squared. It gives me plus 5x minus 3x, which gives me the plus 2x. So that's looking good. So that means that my two x coordinates are minus 1 or 5 over 3. Right, so if x equals minus 1, then y will be 3 plus 5 times minus 1 plus minus 1 squared minus minus 1 cubed. Bit of common sense there, bit of calculator action tells me that y is 0. So that's the point minus 1, 0. And similarly, if x is 5 over 3, then I substitute that into the equation for the graph, and I get y is 256 over 27. So the coordinate of that stationary point is 5 over 3, 256 over 27. So I was asked to find the coordinates of A and B, so those are the coordinates of A, and those are the coordinates of B. And that's question 23 finished. Question 24. The motion of a dampened spring is modelled using this graph. On a separate graph, sketch the gradient function. Choose suitable labels and units for each axis and indicate the coordinates of any points where the gradient function crosses the horizontal axis. Right. So I'm going to draw a set of axes here underneath, here directly underneath, because that's going to make it easier. Right. Now, what we're going to be doing is we're going to be drawing the gradient function. The gradient changes with the time. So this axis is still time, and it's in seconds. Now let's have a look. Sketch this gradient function. Now there are several occasions when the gradient is 0. The gradient is 0 there. So I am going to mark, here we go, there the gradient is 0. So you can imagine dotting a line down here, gives me a gradient of 0 here. Now the gradient of 0, the gradient is also 0 when the time is 1.2. There we go. And the gradient is also 0 when the time is 2.1. Okay. So I can label those points here, 0.5, after 1.2 seconds, and after 2.1 seconds. Okay. Now, the gradient starts off at 0, starts off positively, doesn't it? Then it becomes 0, and then the gradient becomes negative, until it then starts to rise again to 1.2. So it's going to look something like this. Okay, right. Now the gradient is now positive, 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 and then it becomes negative and returns to 0. There we go. All right, now what happens now? Well, the gradient's negative, and then it becomes less negative and tends to 0. So it's going to look like that. Okay, now let's just check the question. Sketch the gradient function. Choose suitable labels and units for each axis. Well, I haven't chosen a unit or a label for this axis. Now this is the gradient function. It's the change. It shows me the change. It shows me the change in displacement over time. Well, the change in displacement over time, of course, is velocity. And how should we measure that? Well, it's in centimeters per second. Choose suitable labels and units for each axis. Indicate the coordinates of any points where the gradient function crosses the horizontal axis. Done. That's 24. Finished. Question 25. The volume of a tin of radius r centimeters is given by this formula. Find the positive value of r for which dV by dr equals 0, and find the value of v which corresponds to this value of r. Right. So we've got a formula for the volume of the tin here, which looks like that. Let's multiply that out. It gives me 40 pi r minus pi r squared minus pi r cubed. Let's differentiate that with respect to r to find dV by dr. It gives me 40 pi minus 2 pi r minus 3 pi r squared. And I need to find the value of r which makes that 0. So let's set this equal to 0 and see what we get. Well, the first thing I'm going to do is take out the pi. It makes me wonder why I didn't take it out, why I multiplied it back in, but never mind. 2r minus 3r squared equals 0. So now I need to factorize this further. I reckon I'm going to have 3r and r. Okay, so I'm thinking about what's going to multiply to 40 and give me minus 2r once I've combined it with the 3r there. So I'm going to try 4 and 10, because 4 threes are 12, and 10 times r gives me 10. So if I can make the 12 a negative and the 10 a positive, then it's going to work out. There we go. So this tells me that r is either minus 4 or 10 over 3. Well, clearly r can't be minus 4. R has to be a positive number. So the positive value of r, for which dV by dr equals 0, is r is 10 over 3. So now I'm going to find the value of v which corresponds to this value of r. Now I know that v is simply pi times 40r minus r squared minus r cubed, and I know that r is 10 over 3. So that's going to mean that v is pi times 40 times 10 over 3 minus 10 over 3 squared minus 10 over 3 cubed. Okay, so altogether there I get a volume of 2,300 over 27 times pi. pi. And that is the question complete. Question 26. The total surface area of a cylinder with a fixed volume is given by this formula. So there's an expression for the area of the cylinder. Okay, where x centimeters is the radius. So obviously as the radius changes, the total surface area changes. That's why the total surface area depends upon the value of x. Show that when the rate of change of the area with respect to the radius is 0, x equals that. Sorry, x cubed equals that. Right, so let's start off with the area formula here. A equals 2 pi x squared plus 2000 x to the minus 1. And let's differentiate that with respect to the radius, with respect to x, because that's now the rate of change of the area with respect to the radius. So that's going to be 4 pi x minus 2000 x to the power of minus 2. Now, we want to set that equal to 0 because we're interested in the value of x cubed when this expression, the rate of change of the area with respect to the radius, is 0. Right, let's multiply everything by x squared. That's going to give me 4x cubed minus 2000 equals 0. So 4 pi x cubed equals 2000. So pi x cubed equals 500. So x cubed equals 500 over pi. There you are. I have shown that when the rate of change of the area with respect to the radius is set to 0, x cubed is equal to 500 over pi. Question 27. A wire is bent into the plane shape ABCD as shown. I've got a rectangle and a semicircle, and yes, the semicircle has a diameter of BD. Absolutely, I can see that from the diagram. The area of the region enclosed by the wire is r meters squared. Okay, AE is x, and AB and ED are y. The total length of the wire is 2 meters. Find an expression for y in terms of x. Well, I know that the total length of the wire is 2 meters. So I'm going to write down an expression for the total length of the wire in terms of x and y and set that equal to 2. So the length of the wire is going to be x plus 2y plus the length of the semicircle. Well, that's going to be pi d over 2, isn't it? So that's going to be pi d, which is pi times x, over 2. So that's the length of the wire, and I know that that has to equal 2 meters. Right, let's simplify that. Multiply everything by 2. Okay, now I need to find an expression for y in terms of x. So I'm just simply going to make y the subject of this. So that's going to be 4 minus 2x minus pi x. So now I'm going to divide everything by 4, gives me 1, minus a half x minus pi over 4x. And there is an expression for y in terms of x. Part B. Right. Prove that r is equal to this expression here. Now, r is the area enclosed by the wire. So, for part B, we need to find an expression for the area enclosed by the wire. Well, that's r. And there's a rectangle, isn't there, which is xy, plus the area of that semicircle. Well, the area of the whole circle would be pi times its radius, x over 2 squared, and we've only got half of that. There we go. So there's an expression for r, because the area is made up of the rectangle plus the semicircle. But of course, I know what y is in terms of x. So I'm going to write x multiplied by 1 minus a half x minus pi over 4x plus, now I've got pi times x squared over 4 times a half. Now I'm going to continue to simplify this. Let's multiply out that bracket. X minus a half x squared minus pi over 4 x squared plus pi over 8 x squared. Right. Now, so I've got an x. Now I've got some x squares there. I'll keep that half minus a half x squared there. Now I'm going to simplify this. I've got minus pi over 4 there and plus pi over 8. So I can write this as minus 2 pi over 8 x squared plus pi over 8 x squared. Right. So that's going to be x minus a half x squared minus 1 pi over 8 x squared. All right, now, if I have a look and see what I'm aiming at, what I'm aiming at is up here. That's not a million miles away from what I've got, I don't think. What I'm going to do is I'm going to take x over 8 out of everything and see what happens. So if I take x over 8 out, then I'm going to need to have an 8 here minus, right. I'm always going to need to have an x there. So I'm going to have 4x, because then if I multiplied out the bracket, I'd get back to a half x squared. And here I'm going to need to have a pi and an x. Right, so I think, look at that, lo and behold, that's exactly what I was trying to show that r was equal to. So part B said prove that r was equal to that expression, and we have done that successfully. Part C, okay, right, here we go, right. Given that x can vary, yeah, okay, well of course x can vary because they can make the plane shape here as wide as they like, can't they? Given that x can vary, using calculus and showing your working, find the maximum value of r. You do not have to prove that the value you obtain is a maximum. Okay, well, I've got an expression for r here. I'm going to use the unfactorized version, x minus a half x squared minus pi over 8 x squared. And obviously I can differentiate that and then find which value of x would be a stationary point. So I'm going to differentiate this expression for r with respect to x. It's going to be 1 minus 1x minus pi over 4 times by x. Now to find the max, what x gives me a stationary point there, which presumably is going to be a maximum, I'm going to set this expression here equal to 0 and solve it for x. So I'm going to add x and pi over 4x to both sides there. Now I'm going to factorize this side, 1 plus pi over 4. I'm going to divide both sides by 1 plus pi over 4 equals x. Now I'm sure I can make that simpler. What about if I'm say x equals, and I multiply top and bottom by 4, so x equals 4 plus 4 pi. So that is the radius that gives me a maximum area. Now the question says find the maximum value of that area, find the maximum value of r. So I'm going to need to now take my formula for r. Here we go. And I'm going to need to substitute in x equals 4 over 4 plus pi into that expression for x. Now, if you do that successfully and carefully, you will end up with r equaling 2 over 4 plus pi. And I'll leave you to sort that out yourselves. And that's 27 done. Question 28. Right, a cylindrical biscuit tin has a close-fitting lid which overlaps the tin by 1 centimetre as shown. There you are. Okay. Right, the radii of the tin and the lid are both x, as they're drawn on the diagram. The tin and the lid are made from a thin sheet of metal of area 80 pi square centimetres, and there's no wastage. All right, show that the volume is equal to that. Right, well, I notice there's no h in that expression for the volume. So we've obviously substituted out the h. So let's have a look and see how we can have done that. Let's imagine for a moment that the height of the biscuit tin equals h. All right, now, of course, we know that the surface area of the biscuit tin has a limit, look. So we could perhaps use the surface area condition to find a formula for h. So let's write an expression for the surface area of the, well, it's not the surface area of the tin, it's the amount of metal used to make the tin, of course. Okay, so metal used, right. Well, there's going to be a circular piece on the top and a circular piece on the bottom. So pi x squared plus pi x squared. Good. Right, now there is the curved face here of the biscuit tin. And there's also the curved face on the lid. Now, if the biscuit tin is h high, then I'm dealing with a rectangle here, which is h plus 1 high, and the area of metal required is going to be that height, h plus 1, plus the circumference of the circle, which is 2 pi x. So here's an expression for the metal used, and I know, by the way, that the metal used is equal to 80 pi. Right, so let's see what happens. 2 pi x squared plus, let's multiply out this bracket, 2 pi xh plus 2 pi x equals 80 pi. Let's divide everything by pi. 2x squared plus 2xh plus 2x equals 80. Let's make h the subject of this formula. So 2xh is going to be 80 minus 2x squared. And so h is going to be 80 minus 2x squared all over 2x, which is equal to 40 over x minus 1 minus x. So there's an expression for h. Now I've been asked to show that the volume is equal to a certain thing. So let's find the volume using that expression for the h. So the volume of the biscuit tin is the area of the bottom, pi x squared, multiplied by h. So that is pi x squared multiplied by 40 over x minus 1 minus x, which is, now, I'm just looking here, if I just multiply my x squared in, leave pi outside, then I'm going to get 40x minus x squared minus x cubed. Now that is that expression there. So I have shown that the volume equals pi lots of 40x minus x squared minus x cubed. And that is part A done. Part B. Given that x can vary, yes, of course x can vary, because I can make this biscuit tin with a bigger or a smaller radius, use differentiation to find the positive value of x for which v is stationary. Okay, well, I know, here we are, part B, I'll do this up here. I know that v equals, I'm going to multiply out that bracket, 40 pi x minus pi x squared minus pi x cubed. That's the volume, right? And I need to find the positive value of x for which v is stationary. So I'm going to differentiate this with respect to x. It gives me 40 pi minus 2 pi x minus 3 pi x squared. And I need to find the value of x which makes that equal to 0. So here is the equation which I'm solving. I'm going to take pi out to start with. Gives me 40 minus 2x minus 3x squared equals 0. So now I'm looking to factorize that like that. I know that I'm going to have a 3x and an x here. I know one of them's got to be negative. I'm looking for numbers which will multiply the 40 and then combine to give you the minus 2x. But beware, of course, because I've got a 3 here as well. So I'm thinking if I put the 10 here and a 4 there, then I get 4 times 3x, which is 12. If I can make that minus 12, and then plus the 10x, that'll work to give me minus 2x in the middle. So my values for x are minus 4 or 10 over 3. Okay, so use differentiation to find the positive value of x for which v is stationary. So the positive value for x, which v is stationary, is 10 over 3. Part C. Prove that this value of x gives a maximum value. Right, well, I know it's a stationary value, but of course I need to prove it's a maximum. So I'm going to need the second differential, I think. So we're going to need to know d2v by dx squared. So I'm looking at this, and I'm differentiating it again. It's going to give me minus 2 pi minus 6 pi x. Now if I substitute in x is 10 over 3, then d2v by dx squared is minus 2 pi minus 6 pi times 10 over 3. Well, obviously that's negative, which implies that x equals 10 over 3 is a maximum. So, prove the value of x gives a maximum value of v. Part C done. Part D. Find this maximum value of v. Okay, well, I know the formula for the volume is pi times 40x minus x squared minus x cubed. I've copied that from the question in part A. And of course, I just need to evaluate that volume now when x is 10 over 3. So it's going to be pi times 40 times 10 over 3 minus 10 over 3 squared minus 10 over 3 cubed. So a bit of calculator use gives me an answer of 2,300 over 27 times by pi, and that is the maximum value of v. Part E. This is possibly the longest question in the world. Here we go. Part E. Determine the percentage of the sheet metal used in the lid when v is at a maximum. So we know that x, the radius is 10 over 3. And we need to work out the percentage of the sheet metal used to make the lid. Well, I know that altogether 80 pi square centimetres of metal is used. So I suppose I just need to work out what the surface area of that lid is, so I know how much of that metal is used in the lid. Okay, so the surface area of the lid is going to be the area of the top, which is pi x squared, plus, now I'm doing the area of the rectangle that runs around the edge here. Okay, well that's obviously 1 high multiplied by the circumference. Well, the circumference is pi d, which is pi times 2x. Right, and I know that x is 10 over 3. So pi times 100 over 9 plus pi times 2 times 10 over 3. Right, okay, well, a bit of calculator action gives me pi times 160 over 9. So that is the area of metal used in the lid. So as a percentage then, it's going to be 160 over 9 pi over 80 pi times by 100. Well, that gives me 22.2%. And that is number 28, finally finished. Question 29. Right, at last we're reaching the end of the exercise. In this diagram, we've got an open tank for storing water. Okay, and you've got isosceles triangles at the end. AD is X. There we go. Show part A that the area of triangle ADE is that. Right. Well, let's have a look at part A. So let's draw that right angle triangle there. Now we know that the hypotenuse is x, we know it's isosceles, and we know that the 90 is there. Let's call each of these sides a for a moment. So I know that x squared equals a squared plus a squared. So x squared equals 2a squared. So a squared equals x squared over 2. And so a equals the square root of x squared over 2. Right, so now I know the length and the base and the height of the triangle. I can find its area, can't I? So the area of the triangle will be a squared, which is going to be x squared over 2, base times height divided by 2, which is going to equal x squared over 4. And there you are. I was asked to show that the area of the triangle was a quarter x squared. And so we have done that, and that's part A done. Okay, 29b. Right. Given also that the capacity of this container is 4,000 cubic meters, and the total area of the two triangle and two rectangular sides is S, show that S is equal to that. Right, let's use this fact we've been given about the capacity of the container. So part B, right. So I know that the volume of the container is 4,000, which means that I know that the area of the end times the length, which I'll call L, must be 4,000. So I know the area of the end is x squared over 4, so x squared over 4 times by the length must be 4,000. So I'm going to use this to give me an expression for L. It's going to be 16,000 over x squared. So now I've got an expression for L in terms of x. I'm going to use that here. So I know the S is the total area of the two triangular sides. Well, that's going to be x squared over 4 plus another x squared over 4, because I know the area of the triangular sides from part A. And now I've got two rectangles, haven't I? Now those two rectangles each have a width there of DE, which is the same as A here. So that's going to be the square root of x squared over 2. That's their width, and then they're going to be times the length, aren't they? Well, I know the length is 16,000 over x squared. Right, let's simplify this. So I'm going to have x squared over 2 there, plus twice times, now the root of x squared over 2 is x over root 2, times 16,000 over x squared. Right, so that's going to be x squared over 2 plus, now I can do some cancelling here, I think. 2 and root 2 there, that's just going to leave me with a root 2 on the top. Right, now the x and the x squared is just going to leave me with an x on the bottom, and now I've just got times 16,000 left. Look at that, it's starting to look as I've been asked in the question. I just need to rewrite that as 16,000 times root 2 over x, and there you are. In the question it says show that s equals x squared over 2 plus 16,000 root 2 over x, and I have done that, and that is part B done. Right, part C. Given that x can vary, yeah, of course x can vary, use calculus to find the minimum value of s. Right, well, here I've got an expression for s. X squared over 2 plus 16,000 root 2 times by x power minus 1. So let's differentiate that with respect to x. It's going to give me x minus 16,000 root 2 over x squared. Now, I'm going to find the minimum value of that, so I'm going to have to set this equal to 0. Equals 0. Right, times everything by x squared gives me x cubed minus 16,000 root 2 equals 0. So I get x cubed equals 16,000 root 2. Bit of calculator action there gives me that x is 28.28 to 4 significant figures. Right, use calculus to find the minimum value of s. Well, that's the value of x. So now I'm going to need to find s when x is equal to that. So I've got this formula for s up here, of course. So I simply need to substitute in x is 28.28 into this formula. And if you do that carefully, you will find the answer is that the value of s when x is 28.28, but make sure you use the whole number, is 1200 square meters. And that is the minimum value of s. Well, we think it's the minimum. In part D, it asks us to justify the value of s you have found to show it is the minimum. So for part D, I'm going to need to use the second differential. Right, here's the first differential. So I'm going to differentiate that again to give me d2s over dx squared, which is going to be 1, and now plus 32,000 root 2 over x cubed. Now let's evaluate that when x is 28.28. Well, when x is 28.28, d2s by dx squared is going to be 1 plus 32000 root 2 over 28.28 cubed. It doesn't actually matter what all this is. The fact is that that's going to be a positive number. So therefore, this x equals 28.28 is a minimum, since the second differential is positive. And that is question 29D done, and that's question 29 done, and that's the whole of the mixed exercise finished. Hurrah for that.